Okay, we have ourselves an infinite series here, and notice that inside of the series we actually have an x value, and the question we're asking is, what are the x values that we could plug in right here that would give us a series that converges? In other words, we're finding the interval of convergence for this series. To do that, we typically use a root test or a ratio test. The ratio test is the more common of the two. And to do a ratio test, we take a sub n plus 1, divide that by a sub n, and then take a limit of that as n goes to infinity. What that means is, for our numerator, we're going to take the term that's inside of this series here, and we're going to replace n with an n plus 1. And then for our denominator, we're just going to take what's inside of the series and put it down there. Okay, and as normal, we're going to need to simplify. Now, needing to do a little bit of algebra is pretty normal for these problems. I'm going to move some terms around, but I'm also going to call this 2x to the n plus 1 term. I'm going to rewrite that as 2x to the n times 2x. You could see this in the last video we did, but again, notice that the powers on 2x are n and 1 here, and if we multiply these two things together, we get 2x to the n plus 1 power. Now I'm going to take this 2x to the n in the denominator and move it over here. I'm going to copy down this n to the 7th, and I'm going to take this n plus 1 to the 7th, and I'm going to move it over here. Okay, so everything that used to be in the numerator is still in the numerator, and everything that used to be in the denominator is still in the denominator. Now notice that our 2x to the n powers can cancel, so I'm going to rewrite this. And I'm also going to rewrite these two terms. Notice that they're both raised to the 7th power, so we can rewrite this as n over n plus 1, that whole quantity, to the 7th power. Now the question we're asking is, what happens to this as n goes to infinity? And you'll notice over here that the powers on n are the same in the numerator and the denominator. What that tells us is that this limit is going to approach the ratio of the leading coefficient of the numerator divided by the leading coefficient of the denominator. That's a long way of saying this limit is going to be 1 over 1, or just 1. So when we take our limit as n goes to infinity, we simply get the absolute value of 2x. And the ratio test says that our series is going to converge whenever that limit is less than 1. Now let's take that and rewrite it up here. And let's recall a little bit of math from some previous math classes. If we have the absolute value of something less than 1, what we can do is we can split this up into a compound inequality. Now we can divide everything by 2, and we get that x has to be between negative 1/2 and positive 1/2. So our basic interval of convergence goes from x equals negative 1/2 to x equals positive 1/2. But we do actually have to test the endpoints of this interval. So I'm going to zoom out a little bit so we can see the whole thing, and let's test the endpoints. That means that we're going to take our x equals negative 1/2 and our x equals positive 1/2, and we're going to plug each of those separately into the original series. If we plug x equals negative 1/2 into our series, notice that in parentheses we get 2 times negative 1/2. That's just negative 1 to the n power divided by n to the 7th. And the question is, does that series converge? Well, it does for a couple of reasons. For one, it's an alternating series, and the term inside of the series goes to 0 as n goes to infinity. 2, if we take an absolute value of this, we'll notice that we get a p-series with p equals 7. 7 is bigger than 1, so this thing converges absolutely. So no matter how we look at it, our series converges when x equals negative 1/2. So what we're going to do is over here in our interval, we're going to include negative 1/2 in our interval of convergence just by putting an equal sign there. Now we can do the same thing with x equals positive 1/2. Notice when we plug x equals 1/2 in, we get 1 to the n in our numerator. That is just 1 in our numerator. So we have 1 over n to the 7th, and that series does converge. Again, it's a p-series with p equals 7. So again, we're going to go back up to our interval of convergence, and we're going to include x equals 1/2 in our interval of convergence. So final answer, our interval of convergence goes from negative 1/2 to positive 1/2, and we're including both of our endpoints. Okay, that does it for that problem. I'll see you in the next one.